Hello everyone, this is DSA Zindabad. Today we are going to solve the 23rd question of Arsh DSA sheet, and the question is print all combinations. Set 2. So now let's look at the problem statement. Given an array of size n, we need to generate and print all possible combinations of our elements in the array. Now let's discuss what does the problem statement says, right? This is the array 1, 2, 3, 4, right? And the R value is equal to 2. So what we need to do, the output will be something like this. Like our goal will be to generate all possible combinations of our element. So the length would be 2 over there. So from there we can directly see the output will be something like this. If we include this this will be the possible combination for including one element. 1 2 1 3 1 4, right? Same goes for 2 2 3 2 4. Same goes for 3 as well. So this will be the total number of combinations. So we just need to print all those combinations of our elements in the given array, right? I hope this problem statement is clear to all of you guys. Now let's jump into the approach and try to figure out how we can solve this question, right? So now there is one idea which comes in my head, we need to generate all possible combination. So what's the approach that will be following is some sort of like a recursion, I can say. Some sort of a recursion, I can say, right? A recursion plus backtracking, right? Because we need to check for each and every element, right? So we'll be using this approach, recursion plus backtracking, in this question, right? So now let's just take the example and try to figure out how we approach this, right? So now let's say we have this array, which is 1, 2, 3, 4, 5, right? This is our array, and the R value will be equal to 3. So now let's do a dry run and try to figure out how we are going to solve this, right? So first of all, what we'll be doing, we'll take all the possible combination which start with 1, right? When we include, this is when we include 1, right? So now after this, after choosing one element, what are the choices we have? Either to include 2 or either we don't include 2. So let's first of all take this case when we include 2, right? 1 and 2, right? This will be now after this, uh, what are the choices we have? Like either to include 3 or do not include 3, right? So let's take when we include 3, right? So this will be the first combination of length 3 when r is equal to 3, right? So at now, after this, we'll directly stop and return over there. So after this, we'll go to when we do not include 3. When we do not include 3, this means we include the next element, which is 4 over there. So the next combination can be 1, 2, and 4, right? When we include 4. So again, after this, we'll directly return to this. And again, what we'll have another possible combination, which is 1, 2, 5, when we include the fifth element, this element, right? So now again, what we'll do, we'll directly backtrack to the 1 again. Now, what is the choice over there? Like when we do not include 3, this means we include 3 over there. When we don't include 2, this means we include 3, right? When we include 3, this is the combination 1, 3. And now at 1, 3, we'll have the same combination, either to include 4 or do not include 4. When we include 4, this will be the combination 1, 3, and 4, right? So now after this, we'll again return, right? So now after returning, what are the possible choices we have to include 5? So we'll have 1, 3, 5, right? So again, we'll return to this, and this will also return to 1, right? So now at this point of time, what are the choices we have? Like when we include, when we do not want to include 2, don't want to include 3, now we want to include 4. So now when we include 2, 4, so we'll have 1, 4. So over there, we'll have only one choice, either to include 5, right? So we have 1, 4, 5 element over there. So it will directly return to this and it will directly return to 1. So now at this point of time, you can see like we have a total of around first, second, third, fourth, fifth, sixth, right? Six possible combinations of length equal to 3, right? So now we'll go to the case when we do not want to include 1. This means we want to include 2. So we'll go to the element 2 now. So now let me just do a line over there so that this this is of 1. Now we'll take the case for 2. Now when this is the case for 2. Now we have a choice to include 3. When we include 3, then we'll have 2 comma 3. Now again we'll have the choice of including 4 or either not including 4. So we'll have 2, 3, 4, right? So now again we'll return. So now at this point of time we'll have the another choice, which is we go for 5. So now we'll have 2, 3, and 5, right? So again we'll return to this function like 2, 2 comma 3. Now it will return to 2. So now when we don't want to include 3, this means we want to include 4. 2, 4. So at this we have 2, 4, 5, right? So again we'll directly backtrack to 2. Now this will also backtrack to this. So now at this point of time, when we don't want to include 2, neither 1, neither nor 2, right? So this means we want to include 3, right? So after this, we'll have the case for 3, right? When we do this, when we want to include 3. So now for 3, what we'll have, we want to include 4. We'll left only like with the possibility to include all the 3 elements. So when we include 5, we have 3, 4, 5, right? So this will backtrack again, backtrack again, backtrack again. Now after this, we'll find that there are no possible combination which are of length 3. So we would stop now, right? So now you can see like we'll have a total combination 7, 8, 9, 10, around 10 possible combinations, right? Of length this, which is 3 over there, and the size of the array is 5, right? So we'll have a possible combination of 5 C3, right? 5 factorial, 2 factorial into 3 factorial, right? 5 into 4 into 3, right? So this will be 3 factorial by 3 factorial, 2 to the 4. So we'll have 10 possible combination. This is the formula for calculating the total number of possible combination which we can have, right? Which will be equal to NCR, right? Where N is the size of array, right? And R is size of R, right? So by like using this formula, we can directly calculate the number of possible combinations which we can have. Like there is a twist in this question. Like let's say if we found some kind of like duplicate element, is there be a different approach for the same or we can follow the same approach? Yeah. So now let's discuss this. So in case of duplicate element, right? Duplicate element, right? What we need to follow in case of duplicate element, uh, like the above method doesn't handle duplicates, right? Let's say if we have example 1, 2, 1, 2, and 1, right? And the R value is 2. So the above program prints something like 1, 2, and 2, 1 as two different possible combination. So we can avoid this kind of like duplicacy, like by just adding two following things to the above approach. Like what we need to do, first of all, we'll sort the array, right? First of all, we'll sort the array. This is our first step. And the second step will be what we need to check if current element is equal to previous element. This means let's say like after sorting, this array will become something like this 1 1 2. So let's say this is our current element and this is our previous element. This is our current element, this is our previous element. So what we need to check, if our current element is equal to previous element, this means we find the duplicate element. So at this point of time, like when this will be equal to previous element, then we need to skip that element. Skip element. Then we need to skip the element. Yeah, like after just adding these two lines in the above approach, I guess we are good to go. Now let's discuss the code. Now let's have a look on the code as well. This code can be found on the GFG website also. So let me just paste the code over there for you guys. So here is the code. Now let's look at the code also. Uh, Initially, what will we have? We'll have this array, and now with r value is equal to 3 over there. So we'll directly call this function, which is print combination. So this is our print combination function, right? Print combination function, which will directly print all the combination, right? So initially we'll have a temporary array to store all the possible combination one by one, which is data of r, right? So now, first of all, what we need to do, we need to sort, right? This is for avoiding all the duplicates. So now after sorting, what we'll do, we'll directly call our major function, which is combination util, right? This will be our major function, right? So now if index is equal like current combination is ready, then we'll directly print it. So we'll directly like run a for loop. So we'll directly print the combination, print combination, right? So when no more element are there to, then we just need to return, right? So when current index is included, then we just need to put next at the next location. Then we'll directly increment our index, right? Like let's say we have this combination 1 2 3 4 5, right? Let's take this example, right? Let's say we when we include 1 and 2, so after this, like we'll need to increment our pointer. So we'll have our pointer like by index plus 1, right? So we'll directly increment index plus 1, right? So now we need to remove all the duplicate. This is for checking this condition. Let's say we have 1 1 2, like after sorting, initially we'll have 1 2 1. So after this, we'll have 1 1 2. So at this point of time, we need to skip this. At this point of time, what we need to do, we need to skip this element, skip the duplicate. So when after like doing this, like skipping, skip duplicate. So after this, what we need to do, like replace when this condition is satisfied, what we need to, when current is excluded, right? Let's say if we don't want to include this item in our list, then we replace it with the next. Note that I plus 1 is passed, but index is not changed, right? So at this point of time, we need to point to this rather than this when we don't want to include the current element. So as we can see, like we are just following the technique of include or exclude, like whether we want to include or exclude a particular element in our output or not, right? We just need to follow this condition and then I guess we are good to go, right? I hope this code is clear to all of you guys. If not, like just do a dry run by your own, by trying all different possible combination which you can have, like, right? By taking some different example, by creating your own example, right? So that this thing will be clear to all of you guys. Now let's discuss the time and space complexity for the same. Time complexity, since we are sorting the array, so it will be big of n log n, right? And also what we are doing, we have two choices, either to include or exclude. So as we can see, like over there we have like a kind of tree over there which have two choices, right? So its time complexity would be big of 2 raised to power n, so which will be ultimately big of 2 raised to power n, right? Now talking about the space complexity, as you can see like over there, now let's find out if we are using a temporary array or not. Like over there, initially we'll have this array. As you can see, like over there, we are using a temporary array to store all the possible combination one by one, right? Over there, size of R, temp array, right? We have temporary array. So this will require big of R space complexity, right? So ultimately, our space complexity would be big of R by making temp array to store combinations, right? To store combinations. I hope this thing is clear to all of you guys, like what would be the time complexity and space complexity, right? Thank you so much for viewing the video till the end. Please do like, share, subscribe, and comment if you have any doubt. Thank you so much.